On a humid Tuesday morning in late August of 2024, Liam Vane stood on the edge of the Cedar Creek ravine and felt the weight of a $15 million contract pressing down on his shoulders. Below him, the center span of the new Cedar Creek Bridge, an 80-ton architectural marvel of reinforced steel, was currently buried 4 feet deep in a deposit of Missouri River muck that the locals called blue gumbo. To understand the scale of the disaster, you have to understand Liam Vane. At 29 years old, Liam was the youngest senior project manager in the history of Apex Infrastructure. He didn't just build bridges, he disrupted the construction industry. He had a degree from MIT, a fleet of drones that mapped every square inch of his sites in 3 dimensions, and a wardrobe of high-tech, moisture-wicking field gear that cost more than a used pickup truck. Liam believed in data, in precision, and in the absolute superiority of modern engineering. He often told his crew that if a problem couldn't be solved with a laptop and a hydraulic manifold, it wasn't a problem worth having. The Cedar Creek project was supposed to be his ticket to the corporate office in Chicago. It was a high-profile, fast-track bridge meant to reconnect 2 halves of a growing county. But 3 days ago, a subterranean spring that had been missed by the initial geological surveys turned the staging area into a literal trap. As the primary crane team began the delicate process of sliding the 80-ton span onto the concrete abutments, the ground beneath the leading edge of the girder simply liquefied. The sound was something Liam would never forget, a wet, sucking thud followed by the groan of 80 tons of steel twisting as it slipped off its rollers. Now, the span sat at a 30-degree angle, one end resting securely on the east bank, the other wedged deep into the blue gumbo. Every hour it sat there, the suction of the clay tightened its grip. "Give me the diagnostics again," Liam barked, not looking away from the ravine. Standing next to him was Sarah Jenkins, the lead site engineer. She was looking at a ruggedized tablet, her face pale in the harsh Missouri sun. "It is the same story, Liam. We have positioned the Twin Grove GMK 7550 cranes as close to the stable shelf as possible. That is $2 million worth of lifting capacity. But every time we engage the winches, the sensors trigger an automatic shutdown." "Override the sensors," Liam snapped. "We cannot," Sarah replied, her voice strained. "These are smart machines, Liam. They are designed to protect their own hydraulic seals and structural integrity. The computer calculates the resistance of the mud, adds the dead weight of the steel, and determines that the force required to break the suction exceeds the safety margin. The software thinks the crane will tip or the boom will snap, so it simply cuts the power. It is a digital deadlock." Liam paced the edge of the gravel road, his designer boots kicking up dust. He had already spent $75,000 in 3 days on specialized recovery consultants from St. Louis. They had brought in high-pressure water jets to try and liquefy the mud around the girder, but the underground spring just replenished the gumbo as fast as they could clear it. They had tried heavy-duty industrial winches anchored to concrete pilings, but the pilings had simply been dragged through the earth like toothpicks through cake. "What about the sky crane?" Liam asked, referring to a heavy lift helicopter. "I called them," Sarah said. "The nearest one is currently fighting fires in California. Even if we could get them here, the cost is $40,000 a day just for the mobilization." And they told me the same thing the crane operators said. If they cannot break the suction immediately, they risk dragging the helicopter out of the sky. 80 tons of steel in a vacuum of mud is not just 80 tons anymore. It is effectively 300. Liam looked at the span. It was a mocking, immovable monument to his failure. He could see the headlines in the industry journals already. "The boy wonder buries the bridge." He felt his career slipping away into the same muck that held his bridge. The local news crews were already parked at the entrance to the site, their satellite uplinks pointed at the sky. The county commissioners were calling his cell phone every 20 minutes, demanding to know why a project that was 50% over budget was now 100% stuck. "There has to be a way to trick the hydraulics," Liam muttered, mostly to himself. "We need a burst of raw power that doesn't trigger the safety governor." "Power isn't the problem," a new voice said. Liam turned, ready to snap at whoever had interrupted his brooding. Standing behind them was an old man in faded denim overalls and a cap that had the logo of a tractor company that had gone out of business 40 years ago. He looked to be in his late 70s, his skin the color and texture of a well-worn baseball glove. He was leaning against a rusted fence post, watching the chaos with the detached curiosity of a man who had seen everything and was in no hurry to see it again. "And who are you?" Liam asked, his voice dripping with the condescension of a man who had an MIT ring on his finger and $1 million problem on his hands. "Name is Silas Thorne," the old man said, his voice a low, gravelly rumble. "I own the 40 acres on the other side of that creek. Been watching you boys play in the dirt for 3 days now." "Well, Silas, as you can see, we are a bit busy," Liam said, turning back to the ravine. "This is a closed construction site. For your own safety, you should head back to your farm." Silas didn't move. He spat a bit of tobacco juice into the dust and nodded toward the stuck span. "You're trying to pull it out like you're pulling a tooth, son. All that fancy equipment is too smart for its own good. It knows when it's beat, so it quits. You don't need a machine that knows when to quit. You need one that's too stubborn to notice." Liam rolled his eyes at Sarah. "Thank you for the philosophical insight, Silas. Now, if you'll excuse us, we have real work to do." "I can pull it out," Silas said simply. The silence that followed was broken only by the distant hum of the idling crane engines. Liam slowly turned back to the old man. He didn't laugh, not yet. He just looked at the old farmer as if he were a specimen of a disappearing species. "You can pull out 80 tons of steel buried in 4 feet of gumbo," Liam repeated. "With what? A team of oxen? Your pickup truck?" "Not with my truck," Silas replied, completely unfazed by Liam's tone. "With my steamer, a 1915 case steam traction engine, 110 horsepower at the belt." Now Liam did laugh. It was a sharp, biting sound. 110 horsepower. "Silas, I have 4,000 horsepower sitting in those cranes right now, and they can't budge that span. Your steamer belongs in a museum, not on a modern infrastructure project." "Your machines make horsepower," Silas said, stepping closer. "Horsepower is for speed. My steamer makes torque. There is a difference. Your cranes are like a thoroughbred horse, fast and strong until it gets a whiff of danger. Then it bolts. My engine is like a snapping turtle. It doesn't move fast, but once it bites onto something, it doesn't let go until the sun goes down or the job is finished." Sarah, who had been listening quietly, looked from the old man to the bridge span. "Silas, even with torque, the sheer physics of the suction..." "Suction is just a force, Missy," Silas interrupted gently. "Any force can be beaten if you apply the right counterforce from the right angle for long enough. Mechanical advantage doesn't care about the year a machine was built. It only cares about leverage." Liam checked his watch. He was losing $2,000 an hour in equipment, rental, and labor. He looked at the old man, then at the museum piece sitting in the distance, a dark, bulky shape peeking out from Silas's barn. "Fine," Liam said, his voice tight with desperation and spite. "Bring your antique, but I'm telling you now, when you blow a boiler or snap a piston trying to play hero, I'm not responsible for the scrap metal you'll be hauling home." "I wouldn't worry about my engine, son," Silas said, turning back toward his farm. "She's been waiting 109 years for a challenge like this. You just make sure your boys are ready to move when that span starts to breathe." The sound reached the Cedar Creek site before the machine did. It was not the high-pitched whine of a modern diesel or the electronic hum of a hydraulic pump. It was a deep, rhythmic chuffing, a sound that seemed to come from the lungs of a giant, ancient beast. With every pulse, the ground vibrated slightly, a heavy, low-frequency thrum that made the coffee in Liam's designer travel mug ripple in perfect time. Liam Vane stood with his arms crossed, his face a mask of skeptical amusement. He had seen the showman types before, contractors who made a show of massive machines and raw power. But this was different. This was, as he had called it, a museum piece. When the machine finally crested the rise, even the crane operators stopped their chatter. It was a 1915 case steam traction engine, 22 tons of black iron and polished brass that looked like it had been stolen from the set of a period film. Its rear drive wheels were 6 feet in diameter, studded with aggressive steel cleats designed to bite into the earth. A thick plume of black coal smoke rose from the vertical stack, and white steam hissed from the relief valves, cloaking the iron monster in a ghostly veil. Silas Thorne sat high on the open operator's platform, his hand resting casually on a massive iron steering wheel. He didn't have an air-conditioned cab, a digital display, or a single sensor to tell him what the machine was doing. He didn't need them. He moved the engine with a stately, unhurried grace, bringing it to a stop exactly 200 feet from the edge of the blue gumbo swamp. Liam walked toward the engine, his boots crunching on the gravel. "I have to admit, Silas, she looks great for her age, but looking good and pulling 80 tons of bridge out of a vacuum are two very different things. My Grove cranes have computerized load balancing, They are built for precision. Your machine was built for... What? Threshing wheat in 1910? She was built for work, son, Silas said, climbing down from the platform with the steady movements of a man who had nothing to prove. The kind of work where you don't go fast, but you don't ever stop until the job is finished. Your cranes are designed to protect themselves. When they feel a load that might cause damage, the computer tells them to quit. This steamer doesn't have a computer. It doesn't know how to give up. It just pulls until either the load moves or the world ends. Liam chuckled, a meaner sound than before. Physics doesn't care about stubbornness, Silas. It cares about force. My equipment makes 10 times the horsepower of that antique. Strength isn't the problem, Silas replied, walking toward his trailer. Application is. You are trying to rip that bridge out in one big burst of speed. Hydraulics are great for lifting, but they reach their limit and they stall. My system is about mechanical advantage and patience. It's the difference between a hammer and a lever. Behind the engine, Silas was towing a heavy, custom-built trailer. He began unloading equipment that looked like it belonged in a museum of industrial archaeology. There were massive pulleys, blocks, and tackles the size of trash can lids and chains with forged steel links as thick as a man's wrist. "You're going to use chains?" Sarah Jenkins asked, her engineering mind finally overriding her disbelief. "We snapped a 5-inch steel cable yesterday. Cables don't have any give," Silas explained as he began uncoiling the iron links. "When a cable hits its limit, it snaps like a piano wire. A chain like this stretches just a hair before it goes. It gives the iron a chance to breathe, a chance to find its grip." Liam watched as Silas spent the next hour walking the edge of the ravine. The old man didn't rush. He used a steel rod to probe the depth of the mud, occasionally kneeling to feel the consistency of the blue gumbo. He was studying the bridge span the way a surgeon studies a complicated fracture, looking for the exact points of attachment that would allow him to apply force from the right angle. "He's wasting time," Liam muttered to Sarah. "The sun is going to be down before he even hooks up." "Maybe," Sarah said, her eyes fixed on Silas. "But look at what he's doing. He isn't just hooking up to the center. He is setting anchor points 30 feet back from the edge. He is building a web. He told me he's going to use a block and tackle system that multiplies his force by a factor of 6. 6 times 110 is still only 660, Liam counted. "My cranes are rated for hundreds of tons of lift. The math doesn't work." "It's not just about the peak force, Liam," Sarah whispered. "It's the duration. The cranes hit a peak, the sensor detects a spike, and it shuts down to prevent a hydraulic blowout. Silas is going to apply a constant, unwavering pressure. He isn't going to jerk it, he's going to lean on it." By mid-afternoon, Silas was ready. He had waded into the muck himself, ignoring the ruin of his overalls, to wrap the main pole chain around the lower flange of the bridge girder. He had threaded the massive chains through the pulley system, connecting the entire web back to the drawbar of the case engine. The construction crew had gathered at the edge of the shelf, a silent gallery of modern workers watching an ancient ritual. The contrast was jarring: the high-tech bridge, the yellow cranes with their digital displays, and the black, soot-stained steamer that looked like a ghost from the 19th century. Silas climbed back onto the platform. He checked the brass pressure gauges, which were trembling near their maximum rated capacity. He reached for the heavy iron throttle, his hand steady and sure. "You sure about this, Grandpa?" Liam called out, his voice finally losing some of its edge. "If that boiler lets go, or if that chain snaps, someone is going to get hurt." Silas didn't look at him. He was focused on the engine, listening to the hiss of the steam and the heat of the fire. "I've been driving this machine for 50 years, son. She knows me, and I know her. If she tells me she can't do it, I'll stop. But she hasn't said a word yet." He shifted the heavy gears into place. The metallic clank echoed through the ravine. "Watch the mud," Silas commanded, his voice rising above the hiss of the steam. "When the span starts to breathe, you'll see the gumbo crack. That's when you'll know the ghost has got its torque." Liam took a step back, his heart racing in spite of himself. He had spent his career believing that the newest, most expensive tool was always the best. But as the steam engine began to roar, a deep, earth-shaking sound that made the very air feel heavy, he realized that he was about to see a kind of power that wasn't written in any of his textbooks. Liam Vane watched Silas Thorne move with a methodical, almost infuriating slowness. While the sun climbed toward its zenith, Liam's frustration simmered. He held his tablet like a shield, the screen displaying a complex array of force vectors and hydraulic pressure warnings that had dictated his every move for 3 days. "Silas, look at the telemetry," Liam said, stepping into the old man's path. "The Grove cranes are drawing nearly 500 tons of combined line pull before the safety governors trigger a total lockout. We are talking about a vacuum of mud that creates suction forces the likes of which you've never seen. You have a machine that makes 110 horsepower. Even if you multiply that by 6 with your pulley system, you are barely breaking 660 horsepower. The math doesn't work. You are bringing a toothpick to a gunfight." Silas didn't look up from the massive iron block he was shackling to a buried concrete pylon. "You're still thinking in horsepower, son," Silas said, his voice as steady as the rhythmic breathing of his engine. "Horsepower is just a measurement of how fast you can do work. It's a salesman's number. But that bridge span down there doesn't care about speed. It cares about torque and persistence." Silas stood up, wiping grease onto a rag that had seen better decades. He pointed a calloused finger at the yellow cranes, sitting idle at the edge of the ravine. "Your machines are smart," Silas continued. "They've got sensors and computers designed to protect the equipment from damage. When the load gets too heavy, the computer senses the strain and cuts the power to prevent a hydraulic blowout or a snapped boom. That's smart engineering for 99% of the world. But this swamp is that other 1%. Liam crossed his arms, his designer field jacket crinkling. "And your machine is smarter?" "No," Silas chuckled, a dry sound like gravel shifting. "My steamer is dumb. It's 22 tons of iron, water, and fire. It doesn't have a nervous system, and it doesn't have a sense of self-preservation. It only knows one thing: pulling. If I tell it to pull until the gears strip or the boiler cracks, it'll do exactly that. The only computer on this site is between my ears, and I know when to stop and when to keep leaning." The physics of the web. Silas turned back to his work, and Liam found himself following, drawn in by the sheer audacity of the setup. Silas wasn't just hooking a chain to the bridge and pulling in a straight line. He was constructing what he called a force multiplier web. The anchor points. Silas had identified 4 distinct points of stability. He drove 6-foot steel stakes into the hard clay shelf, 30 feet back from the ravine's edge, creating primary anchors for his pulleys. Mechanical advantage. He began threading a massive, 1-inch thick forged steel chain through a series of 6 heavy-duty pulleys. Silas explained that every pulley in the sequence reduced the force needed to move the weight by half, effectively multiplying the engine's raw pulling power by a factor of 6. The give of the iron. Unlike the 5-inch steel cables Liam had snapped the day before, Silas insisted on using heavy chain. "Steel cable is rigid," Silas muttered as he tightened a shackle. "It doesn't stretch. When it hits its limit, it just explodes. But iron chain has a tiny bit of give. It can stretch a fraction of an inch and hold that tension. It allows the force to build up slowly, like a spring, instead of hitting the load like a hammer." Sarah Jenkins, the site engineer, watched Silas with a mixture of professional skepticism and growing fascination. She walked the line of the chain, checking the angles. "He's not trying to lift the span, Liam," she whispered. "He's trying to break the surface tension of the gumbo. He's angled the main line so it pulls the leading edge of the girder upward and outward at a 15-degree angle. It's a leverage game," Silas called out, hearing her. "A lever is more powerful than a hammer. Your cranes are trying to overpower the mud. I'm going to use physics to make the mud give up." The arrival of the tension. By 2 o'clock in the afternoon, the setup was complete. The bridge span was wrapped in a web of chains and cables, all converging into a single, massive master link connected to the drawbar of the 1915 case engine. Silas climbed back onto the operator's platform. He began shoveling coal into the firebox, the orange glow reflecting in his eyes, as he built the steam pressure to 175 pounds per square inch. The engine hissed, white plumes of steam escaping from the relief valves, making the machine look as though it were breathing. "Everything is about the first 3 inches, Silas shouted over the roar of the fire. "Once we get the air underneath that girder, the vacuum breaks. But until then, we are fighting 300 years of Missouri clay that doesn't want to let go." Liam stood near the edge of the ravine, his tablet now forgotten in his hand. He watched the tension take hold of the master chain. It went taut, vibrating with a low, musical hum like a piano wire under extreme stress. The steam engine groaned, its massive 6-foot drive wheels settling into the dirt, the steel cleats biting deep into the earth. "Watch the leading edge," Sarah screamed, pointing toward the bridge. For a long minute, nothing happened. The engine chuffed a deep, rhythmic thump-thump-thump that shook the ground beneath Liam's feet. The coal smoke turned from grey to a thick, oily black as Silas opened the throttle wider. The smell of hot grease, coal smoke, and pressurized steam filled the air, a scent from a century ago that felt strangely more real than the clean, sterile hum of the modern cranes. Then, a sound erupted from the ravine. It wasn't a snap or a crack. It was a long, wet, sucking groan, the sound of 80 tons of steel finally losing its battle with the earth. "She's breathing!" Silas roared, his face split by a wide, triumphant grin. Liam stepped closer to the edge. He could see it now, a thin line of black water and air bubbling up from beneath the buried girder. The blue gumbo was cracking. The ancient, stubborn iron of the 19th century was doing what the computerized precision of the 21st century could not. It was applying a slow, unwavering force that simply refused to take no for an answer. Some problems don't need more power. Silas's words echoed in Liam's mind. They just need better thinking. As the bridge span moved its first 3 inches, Liam realized that he wasn't just watching a rescue, he was watching a masterclass in a kind of wisdom he had never been taught in school. The museum piece wasn't just pulling a bridge, it was pulling Liam's entire worldview apart, piece by piece. The air around the Cedar Creek ravine felt different now. It was no longer the sterile, frustrated atmosphere of a modern construction site, stalled by digital errors. It was thick with the heavy, humid scent of burning bituminous coal, hot cylinder oil, and the sharp, metallic tang of high-pressure steam. Liam Vane stood frozen at the edge of the shelf, his high-tech tablet forgotten in his grip. He was watching a scene that defied every spreadsheet and load-balancing algorithm he had ever studied at MIT. Silas Thorne stood on the vibrating iron platform of the 1915 case, his hand resting on the throttle with the casual familiarity of a man holding a conversation with an old friend. He wasn't looking at a screen, he was looking at the master chain, feeling the tension through the soles of his boots. The engine was chuffing a deep, rhythmic sound that felt more like the heartbeat of a living creature than the mechanical operation of a machine. "All right, old girl," Silas muttered, though his voice was lost in the hiss of the valves. "Let us see if the world still remembers how to pull." He moved the iron lever another notch. The response was immediate. The massive 6-foot drive wheels, studded with steel cleats that looked like the teeth of some prehistoric predator, bit into the gravel and clay. They didn't spin. They didn't kick up a rooster tail of wasted energy like the bulldozers had 3 days earlier. Instead, they settled. The 22-ton weight of the steamer acted as its own anchor, pressing those cleats through the surface mud until they found the solid limestone shelf beneath. The master chain, with links the size of a man's wrist, went tight as a piano wire. It didn't just go taut, it began to hum a low-frequency vibration that Liam could feel in his teeth. This was the moment where the modern cranes had failed. Their computers had sensed the sudden spike in resistance from the blue gumbo, and fearing a catastrophic structural failure, had instantly cut power to the winches. But the case had no such intelligence. It had only the raw, stubborn pressure of steam against iron. "Watch the leading edge," Sarah Jenkins screamed, her voice cracking with excitement. The 80-ton bridge span groaned. It was a sound Liam would hear in his dreams for years, a low, subterranean protest of metal under extreme stress. The girder didn't move forward yet, but it tilted. Silas was using his force multiplier web to pull upward and outward at the same time. He wasn't trying to overpower the entire 80-ton mass all at once. He was attacking the suction. "He is working the vacuum," Sarah shouted over the roar of the engine. "He is pulling the front edge up just enough to let air in." Silas opened the throttle further. The coal smoke rising from the stack turned from a lazy grey to a thick, oily black as the firebox roared with fresh oxygen. The steam engine's chuffing grew louder, faster, more urgent. Chunk, 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 chunk. The ground beneath Liam's feet began to tremble with a frequency that felt like a localized earthquake. In the ravine, the blue gumbo began to fail. A long, jagged crack appeared in the surface of the mud near the base of the girder. It looked like the earth was being forced to open its mouth. A massive bubble of air and muddy water erupted from beneath the steel with a sound like a wet explosion. "There it is," Silas roared, his face illuminated by the orange glow of the firebox. The brake. With the vacuum broken, the 80-ton span suddenly became lighter. It didn't fly out of the hole, but it began to crawl. Inch by painful inch, the steel girder slid through the muck. The pulleys in Silas's system squealed, their heavy iron sheaves turning under loads they hadn't seen in half a century. The force was constant. Unlike the modern hydraulics that delivered power in bursts, The steam engine provided a relentless, unwavering torque that simply refused to take no for an answer. Liam watched, mesmerized. He saw the black, dripping underside of the bridge span emerge from the gumbo like a rising shipwreck. The suction that had defeated $15 million worth of technology was being dismantled by a machine built when Woodrow Wilson was in the White House. The construction crew, men who usually spent their days complaining about slow Wi-Fi or faulty GPS sensors, were now standing in absolute silence. They were watching 60 years of experience and 109 years of iron do what their smart machines couldn't even attempt. "Come on, you beautiful relic," Liam whispered, his skepticism finally replaced by a raw, primal hope. Silas gave the engine one last surge of steam. The case roared, a triumphant, deafening sound that echoed off the rock walls of the ravine. The drive wheels turned with a slow, terrifying power, dragging the span another 3 feet, then 6, until the leading edge finally cleared the lip of the mud and settled onto the compacted gravel of the staging area. The silence that followed was absolute. Silas closed the throttle, and the sudden absence of the engine's roar was deafening. He reached for the brass cord and pulled. The steam whistle let out a long, shrieking blast, a triumphant, high-pitched scream that tore through the Missouri morning, announcing to the entire county that the bridge was no longer buried. Liam didn't move for a long time. He looked at the bridge, now sitting safe and accessible on solid ground. Then he looked at the 1915 case, its black paint streaked with soot and grease, steam still curling lazily from its valves. Finally, he looked at Silas Thorne, who was calmly coiling a grease-stained rag, his face covered in a fine layer of coal dust. The showman, in Liam, wanted to check his tablet, to analyze the data, to find a way to claim the success for the project's overall strategy. But the man in Liam, the one who had just seen 100 years of history pull him out of a career-ending hole, knew better. He walked over to the engine, his boots stepping into the deep ruts left by the massive steel cleats. He reached out a hand, not to Silas, but to the warm, vibrating iron of the boiler. "You were right, Silas," Liam said, his voice barely a whisper against the fading hiss of the steam. "It wasn't about the horsepower." "It never is, son," Silas replied, climbing down from the platform. "It is about the heart of the machine, and knowing that some things were built to never, ever give up." The silence that followed the bridge rescue was the loudest thing Liam Vane had ever heard. It was not a void of sound, but a heavy, meaningful quiet that settled over the Cedar Creek ravine like the dust from the coal smoke. The 80-ton span sat safely on solid ground, looking bruised and muddy but undeniably free. Liam stood by the massive iron drive wheel of the 1915 case, feeling the heat still radiating from the boiler. He looked at his hands. They were shaking, and for the first time in his life, they were covered in grease and soot rather than the clean glow of a tablet screen. Silas Thorne climbed down from the platform, his joints popping with the rhythm of 70-some years of hard work. He pulled a tattered rag from his pocket and began wiping the brass fittings, his movements slow and deliberate. He didn't look for a round of applause or a television camera. He just looked at the machine that had been in his family for over 100 years. "She'll need a good cleaning when we get home," Silas muttered, more to the engine than to Liam. Liam stepped forward, struggling to find the right words. His education at MIT had given him the vocabulary for structural dynamics and fluid mechanics, but it hadn't taught him how to apologize to a man who had just saved his life's work with a pile of iron and steam. "Silas, I don't know what to say. You were right about the talk. You were right about everything." Silas stopped wiping and looked Liam in the eye. His gaze wasn't mean or triumphant. It was simply grounded. "The problem with you young fellas isn't that you're not smart," Silas said gently. "It's that you think the world only started turning the day you bought your first computer. You think expensive means better and new means smarter." He patted the black iron of the boiler. "Some problems don't need more power. They need better thinking, and a machine that doesn't know how to give up." Liam reached into his jacket for his checkbook, the same way Frank Donnelly had done 30 years prior in a different mud hole. "Name your price, Silas. You saved the contract. You saved my career. Whatever you want, it is yours." Silas shook his head, a small smile playing on his weathered face. "I didn't do this for your money, son. I did it because that bridge was acting like it was smarter than the men who designed it." He looked toward the ravine. "If you want to settle the score, do what I told you. Make a donation to the Historical Society. They are the ones who help keep these old ghosts breathing, so they can remind people like you that we've been here before." Liam watched as Silas fired up the engine one last time. The whistle let out a short, cheerful toot before the 1915 case began its stately 5-mile-per-hour crawl back toward the Thorne farm. The steel cleats clanked against the gravel road, a rhythmic sound that Liam found himself recording on his phone, not for data, but for the memory. The Cedar Creek Bridge was finished 6 months later, exactly as the blueprints had promised. The entrance to the bridge featured a graceful curve through the Missouri timber, but at the very start of the span, Liam insisted on one final addition that wasn't in the original budget. He erected a small bronze plaque. It didn't mention Apex Infrastructure or Liam's own name. It simply stated, "In honor of the stubborn iron and the quiet wisdom that built this country. Let us never forget that we stand on the shoulders of those who came before." As the years passed, Liam Vane changed. He still wore the expensive gear, and he still used the latest technology, but his office in Chicago looked different from those of his peers. On his mahogany desk, next to his high-end workstation, sat a framed photograph. It was a picture of Silas Thorne standing next to the 1915 case steam engine on that muddy August morning. When young, arrogant engineers would come into his office boasting about a new software that could solve any problem, Liam would lean back and point to the photo. He would tell them the story of the 80-ton span and the 100-year-old ghost. He would tell them that sometimes the most advanced sensor is the one in your own gut, and the most powerful engine is the one that doesn't have a computer to tell it when to quit. 20 years later, in the year 2044, Liam found himself back at Cedar Creek. He was the senior vice president now, gray at the temples but still sharp. He was watching a young project manager, a kid with a degree from Stanford and a fleet of autonomous construction robots, trying to move a massive concrete pylon that had become wedged in the riverbed. The young man was yelling into a headset, complaining that the robots were triggering safety shutdowns because the resistance was too high. He was threatening to fire the software team and hire a heavy lift transport company at a cost of $500,000. Liam walked over to the edge of the site, his boots crunching on the same gravel he'd walked 2 decades before. He looked across the creek toward the Thorne farm. Silas was gone now, but the barn was still there, maintained by his granddaughter Emma, who had learned to fire the boiler when she was 16 years old. "You having some trouble, son?" Liam asked, his voice a low, calm rumble. The young manager barely looked at him. "The sensors are hitting a hard limit. The physics are impossible. We need more power." Liam smiled, a slow, knowing expression that had taken him 20 years to earn. "Power isn't your problem," Liam said, pointing toward the old Thorne barn where a familiar rhythmic chuffing was beginning to echo across the valley. "Your machines are just too smart for their own good. They know when to be afraid." A black plume of coal smoke rose into the Missouri sky, and the familiar shriek of a steam whistle cut through the air. The young manager looked confused, but Liam just turned and watched the horizon. "Some things don't become obsolete," Liam whispered to the ghost of Silas Thorne. "They just wait for people to remember why they were built in the first place." The 1915 case crested the hill, steam hissing and brass gleaming, ready to remind a new generation that before there were computers, there was iron, and before there was horsepower, there was torque.